All right, so let's go ahead and get started. Today we're going to be doing questions 30 through 38 on the 2015 SOL. If you want to know how to get there, you're going to go to modules. You're going to scroll down to week 17, and it'll be under Wednesday. And you're going to hit the link at the top. So then I'm going to scroll down to 30 of 38. And let's start here. All right, so this one says, as x approaches negative infinity, which of the following best describes the end behavior of this function? So we're given a function. I'm going to go ahead and write it down, and I'm going to graph it. So my function is f of x is equal to negative x to the 7th power plus bx cubed plus c. And for this function, we want to find the end behavior as x approaches negative infinity. So I'm going to say x approaches negative infinity, where this is the infinity symbol. All right, so the first thing that I'm going to do is I'm going to graph this. And for the purposes of this question, I'm going to let b be equal to 1 and c be equal to 1. But they could be any real number. So here in Desmos, I'm going to type in f of x is equal to negative x to the 7th power. And then I have to add 1x cubed plus 1. And that's my function. Okay, so looking at this graph, what happens as x approaches negative infinity? As x approaches negative infinity, which direction am I going? Am I going to the right or am I going to the left? See how the x-axis has the negatives on this side and the positives on this side? If it's negative infinity, we're going to be going to the left because that's going to give me all the negative numbers. So as the function goes to the left, what does it do? It goes up. So how do we say that? As x approaches negative infinity, y is going to approach positive infinity. So the function is actually going up. As you go to the left. And I'll put a box around this. So f of x is going to approach positive infinity. That's going to be c. So you could say y approaches infinity, or you could say f of x approaches infinity, because y and f of x are the same thing. And I'll put a box around this too. Okay, let's look at 31. This one is going to give us a chart where all the x values are on the left side and all the y values are on the right side. So to put a chart and get the data, we need to go to Desmos. So that's where I'm going to go first. I'm going to get rid of this. And then what we're going to do is we're going to add a table. So in Desmos, go to the top left, click Add Item, and then click on Table. So we're going to put all the x values on the left side, 0 through 5. And then the y values are going to go on the right side. So 23,000. Don't put in any commas, please. 20,000, 16,000. 14, 12, 10. Okay, so now I've got all my numbers in. I can't really see them right now, so I need to go down to the bottom of the box and I'm going to hit Zoom Fit. And now I can see all my dots. And then the problem is going to tell you what type of regression you need to use. And the question says exponential. So we're going to be using a times b to the x power. So here's the way I do it. I go down to the next box and I need to type in y1. y1. And then I need the squiggle. If you don't know where that is, you hit the keypad at the bottom and it's going to be under ABC at the bottom. The very bottom row, you'll see it. Then I need AB to the x power. So I'm going to type in A, B, and then I'm going to raise it to the x1 power. And I get this smooth curve. So the first thing that I'm going to do is I'm going to plot my residuals. You'll see them down here on the x-axis. And then I need to type my A and my B. So A is going to be 23,103.4. So that looks like it's going to be C. And then B has to be 0.85. Yep, that's what I get for B right here, if I round up. So for 31, I'm going to choose C. That's my regression equation. And then if I want to write it down, it's going to be 23,100. And then 0.85 to the x power. So that's 31. Now, the question doesn't ask you to do any predicting, so you don't have to do that. You just need the equation. Okay, are we all ready for the next one? Does anybody need me to slow down? Okay, let's look at 32. So 32 tells me I have an infinite geometric series. Infinite geometric series. Now, if you have an infinite geometric series, what's going to happen is you're going to have a sum of numbers, let's say A1, A2, A3, ... And all of these numbers are being added together. And once I add all the numbers, I'm going to get the sum. I'll just call it S, infinity. So the formula for this is going to be S infinity is equal to A1 on top of the fraction. You're going to draw your fraction bar. And then on the bottom, you're going to have 1 minus R. And R cannot be equal to 1 or greater than 1. So it's got to be less than 1. So the question tells me 9 minus 6 plus 4. And then it tells me minus 8/3. So this is the series that I'm given. So the first number is A1. That's going to be the first number in the series. So what's the first number in my series right here? Was anybody able to get that? Nine, right? So I'm going to put 9 on top. And I'm going to need 1 minus R on the bottom. So what is R? R is going to be the number that you got to multiply by each time to get to each new number. So what do I need to multiply 9 by to get to -6? What do I need to multiply -6 by to get to 4? And so on. Well, what you can do is you can take the number and you can divide it by the number that comes before it. So let's choose 4. I'm going to divide 4 by the number that comes before it, -6. And when I divide, I get -2/3. That's going to be my R value. So I put the -2/3 inside the parentheses right there. And I work on the bottom of the fraction next. So 9 is on top. On the bottom, I have a double negative, and a double negative is the same thing as a positive, right? So I can do 1 plus 2/3. Now, if I'm adding 1 and 2/3, what I can do is I can rewrite the 1 as 3/3. So I'm going to erase the 1 and replace it with a 3/3. Okay, so I'm almost there. What's 3 plus 2 at the top? Yeah, that's going to give me 5. So on the bottom of the fraction, I'm going to have 5/3. Now, if I'm dividing by a fraction, that's the same thing as multiplying by the flipped over fraction, the reciprocal. So I can take that 5/3 and I can flip it over and get 3/5. And then 9 times 3 is 27. 27/5. That's going to be the sum of my series. And that is C. So you have to know what the first number is. That's A1. And then you need to know what R is. That's my common ratio. That's what I have to multiply every single time to get to the next number. Okay, let's try 33. This one says, which number is a 0 of f of x? And then it gives me the function. 7x squared, 16x, and minus 48. So the first thing we're going to do is we're going to underline the word 0. And we know that 0 is the same thing as what? The x-intercept, right? So if we can graph this and see where it crosses the x-axis, we'll know what its zeros is. So what I'm going to do is I'm going to graph it on Desmos and look at it. So I need 7x squared plus 16x minus 48. I think that's it. Yeah. Where does it cross the x-axis? I need to hit the home button so I can see it a little bit better. And then I'm going to zoom out a little bit. and this is my graph. So where does it cross the x-axis? Right here and right here. -4 and 1.714, whatever that is. So let's write those down. We got x equals -4 and x equals 1.714. This is probably a fraction. But I'm not sure what fraction it is yet. But these are basically going to be our two answers. So let's see if they show up or not. So the -4 doesn't show up. I only see a +4. And that can't be it, right? It can't be 12. So it's either going to be C or D. Which one makes the most sense? What do you guys think? What is 12 over 7? Let's try it on Desmos. 12 divided by 7 is 1.714. And some other decimal points that we don't care about. So I can write it like this. And 12 over 7 is C. So that's going to be my answer. It's the only one that makes sense, right? Yeah. The other one is 4 over 7. Let's see what that is. 0.5714. And we don't have that. So that's 33. Not every decimal can be written as a fraction, especially pi. So sometimes they're fractions, sometimes they're not. And -4 is a whole number. Okay, everybody ready to move on from this? Okay, let's try 34. Okay, so only write the function for this one. This one asks which function is the inverse of g of x. And it tells me g of x is x cubed plus 11. But we need to find the inverse, which is g -1 of x. So the first thing that I'm going to do is I'm going to change my g of x into a y. So I get y equals x cubed plus 11. So far, so good. All I'm doing is I'm changing the g of x into a y. So only this has changed. The next thing that I want to do is I want to switch the x and the y. Everywhere I see a y, I'm going to put in an x. Everywhere I see an x, I'm going to put a y. So this is going to become y cubed plus 11. But everything stays the same. The exponent of 3 is up here, and the plus 11 is right here. And now what I'm going to do is I'm going to solve for y. Solve for y. So what that means is I want to get y by itself. I want to get y by itself on the right side. So that means I need to get rid of two things. I need to get rid of the plus 11 and the 3. How can I get rid of a plus 11? What can I do to both sides to get rid of that? What can I subtract from both sides? I can subtract 11, right? Let's see what that does. The first thing that it does is it cancels out the 11s, right? So these are gone. I'm only left with y cubed on the right side. And on the left side, I'm going to have x minus 11, like this. So now the only thing I have left to do is get rid of this 3. But it's a cube, right? Exponent 3. How can I get rid of this 3? What can I do to both sides? How do I get rid of a 3 if it's up here? I can do cube root, right? So I'm going to take the cube root of both sides. The left side like that, and the right side like this. And notice the cube root is always going to have an index of 3. So that's going to match up with the 3 on the inside. So these 3's are going to cancel out. So watch this. I'm going to change to red, get rid of this 3 and this 3, and I'm only left with the y now. And then on the other side, I have the cube root of x minus 11. That's my answer. Okay, so you can probably get the answer choice from there. The last thing that I'm going to do is I'm going to change y into my inverse notation, g negative 1 of x, like that. But everything else stays the same. So the cube root of x minus 11, that's basically your answer. There's nothing else I can do to it. So it's going to be A. Now, something cool about inverses that you may not know, but you're about to learn. If you graph the function and its inverse, a special thing happens. And I'm going to show you what that is. So my first function was x cubed plus 11 You can see it on your screen right there. I'm going to graph the inverse. I'm going to call it f of x. Now, I'm going to need the cube root, obviously. So I need to go down to the keypad and grab the cube root. Where is that? It's going to be under functions, I think. Yeah. Go over to miscellaneous, this fourth tab right here, and click on n cube root right here. It'll be beside polygon. And now I can make my index into a 3 and put x minus 11 on the inside. And my inverse shows up in blue. What do you notice about the graphs? How is this red graph related to the blue graph? They're opposites. Yep. So the last thing that I'm going to do is I'm going to type in y equals x. I'll do it in the next box. Y equals x. That's the green line. So notice that if you flip the red function over the green line, you're going to get the blue function. And if you take the blue function and you flip it over the green line, you'll get the red function. So that's how inverses behave when you graph them. Okay, let's go to 35. What is the domain of g of x? Log of x minus 1. So g of x equals log of x minus 1, and it's asking for the domain, right? So the domain is the set of all what? Anybody know? X values, yep. So what we're going to do is we're going to graph it, and we're going to see which x values show up and which ones don't. So the domain is going to be the set of all x values. And for the purposes of this function, every logarithm is going to have a base. The base is just a number. So we're going to assume that the base is 10 for now. So it's really log base 10 of x minus 1. And we're going to graph that on Desmos and see what it looks like. Okay, get rid of all this stuff. G of x equals log of x minus 1. That's my function. I'm going to zoom in on it. So which x values show up and which ones don't? So let's think about it. Where does the function start at? From the left side. I know that it comes up from the bottom, but it never passes this vertical line right here. We call that a vertical asymptote, right? What is that vertical asymptote? X equals what? 1. So it never hits 1. It gets infinitely close to it, but it never crosses it. So I'm going to type in x equals 1. And I'm going to make it a blue dotted line. So check it out. I'm going to zoom in on it. Notice how the purple function never crosses this dotted line right here. It gets very close to it, I'll admit, but it never crosses it, ever. So what can we say the domain is? every number that's greater than what? 1. Yep. So x has to be greater than 1. That's the domain. Because we have a vertical asymptote there. And the way you can tell is you got an x minus 1 on the inside. And that should give you a hint. That's how you know what the vertical asymptote is if you didn't graph it. And that's going to be C. X is greater than 1. Okay, let's do 36. Okay, this one looks like another chart question. So you already know what you got to do. And here's your regression once again. Yeah. Okay. So let's go to Desmos. Let's get rid of everything and start a table. We'll put all the x values on the left side, so 0 through 4. And then the y values are going to go on the right side. 80, 56.6. And then what does it say? 40, 28.3, and 20. So if you hit zoom fit, you can see all the dots right where they should be. So now I'm going to do my regression, y1 squiggle, ab to the power of x1. And that's my line. And I can plot my residuals down there. So what are my parameters? A equals 80 if I round it to a whole number. And then B, if I round that, it's going to be 0.71. So Y equals 80, 0.71 to the x power. And that's my equation. Okay, so which answer choice best matches this? Okay, they don't give you an equation, but they do ask you to make a prediction, right? And this one says, if it continues at the same rate, what happens to y if x equals 5? What if x equals 5? Does everybody remember how to do a prediction? Let's try it. So I'm going to go to the next box and I'm going to type in f of x, my function notation. And I'm going to type in my 80.0086. And then in parentheses, I'm going to type in my 0.707. 168. And then go ahead and raise that to the x power. You can see that it becomes the black function right here. And then I can let x be 5 down here. So then if you let x be 5, your y value is going to be 14.15. Just about. And that's going to be D. So that's what I would write for that one. Okay, raise your hand if you need any more time for that. Nobody? Okay, let's go to 37. Okay, so this one says, what is the sum of the first 20 terms in this sequence? So first thing is, let's write down the sequence. So we got 1/3, 2/3, 3/3, which is 1, 4/3, 5/3, and eventually you'll get 6/3, which is 2, and then so on and so forth. So that's my sequence. Now, every sequence is going to have a first term. My first term for this one is going to be 1/3. I'm going to circle it, put a box around it, and I'm going to call it A1. That's my first term. And then I'm going to figure out what D is. D is going to be the number that I have to add each time to get to each new number. So what am I adding each time? Anybody know? 1/3, right? So not only is A1 going to be 1/3, D is also going to be 1/3. And then I'm going to need a value called N. N is how many numbers you have. And in this case, it says 20. So my N is going to be 20. That's how many terms I'm going to have. So the next thing I'm going to do is I'm going to figure out what the last term is. What would be the 20th term? So what I could do is I can use the nth term formula, which is A1 plus n minus 1 times d. So the first thing that I need is A1. That's going to be 1/3. My n is going to be 20. And the d for this is 1/3. So the next thing that I can do is I can do 20 minus 1. Twenty minus 1 is what? 19. And then I have to multiply it by 1/3. So I get 19 over 3. And then the last thing I'm going to do is I'm going to add 1 and 19. That's going to give me 20. (20)3. Now, that's not my final answer. That's just the last term, A20. But it's asking me what is the sum of the first 20 terms. So basically, you need to add up all of these numbers until you get to 20 over 3, and then you stop. So here's what that looks like. I'm going to have 1/3 plus 2/3 plus 1 plus 4/3. And I'm going to keep on going until I get to 20/3. And then I'm going to stop. And I'm going to call that S20 because S stands for sum. So let's find the arithmetic sum. The formula for this is going to be Sn is equal to n divided by 2 times A1 plus An. And this is the formula that we're going to be using to find S20. So what I'm going to do is I'm going to let n be 20 and see what happens. The first thing I'm going to do is I'm going to replace n with 20. And I get 20 over 2. And then the next thing that I need is A1 and An. What's A1? 1/3. Yep. That's the first term in the sequence, this right here. And then what is An? Yeah, 20/3. That's going to be your last term. What's 20 divided by 2? 10. Yep. What's 1/3 plus 20/3? Which is 21 over 3, 7. Yep. So 21 over 3, that's actually 7, like you said. So I'm going to rewrite it as a 7. And then 10 times 7 is 70. That's my answer. So keep in mind, you're adding up all these numbers up here. And there's 20 numbers in total, but you got to add them all up. And you get 70. So you can do it the long way, like you could put all this in the calculator and just add up all 20 numbers, that's fine. But you could also do it this way by formula. So does 70 show up? Yep, it's C. Okay, last one. 38. What is the number of permutations of 8 objects taken 3 at a time? I think that's it. Yep. Okay. So the first thing to know is we're finding permutations, not combinations, permutations. So I'm going to be using a P. The next thing that you need to know is how many objects in total do you have? How many objects do I have in total? 8, right? How many am I choosing at a time? 3. So I need to find out what 8p3 is. Now, if you put it in the formula, you could do it like this. And you can figure out what that is. Or you could type it into Desmos and it'll figure it out for you. So I'm going to go to Desmos and I'm going to type it in. First, I'm going to need the permutation formula. That's going to be under functions. And then if you go under functions to, I think it's stats, you'll see NPR at the bottom. I'm going to click that. And then the 2 numbers are 8 and 3. I'm going to separate them out by commas. And then the answer is going to be at the bottom of the box, 336. So 336, that's my answer. Now what you can also do is you can do it by formula, right? At the top, I have 8 factorial, but at the bottom, I'm going to have 8 minus 3. That's 5 factorial, right? So then if I write this out, it's going to be 8 times 7 times 6 times 5.
Your attention for 2 announcements. Students that ride bus 167 need to ride bus 90 today, and students that ride bus 76 need to ride bus 123. Thank you.
And then the 5 factorials are actually going to cancel out on the top and the bottom. So then you really have 8 times 7 times 6, which I assume is 336. I haven't tried that, but I think it's true. Yep, 336. Good. Since there's no answer choice, you're just going to write down 336. That's it.